Okay, so this is slightly different than what we talked about yesterday. These are going to be more in the format that look like this. So we're going to have a rate that we're either going to have to add or subtract from 1 or add or subtract to 1. So this one says 8% each year, and we're starting at 150,000. So I'm going to jump down to B. We're going to go 150,000, and we're going to say 1 plus, this says 8%. 8% is the same as saying 0.08. So 1 plus 0.08 to the x. So we can simplify that. 1.08 to the x. This is what you would put in your calculators. Okay, so for this part where we have to raise it to the 10th, we take care of this part first, raise it to the 10th, and then multiply our answer by 150,000. So we should end up with, if we round, anytime this number in here is bigger than 1, it's going to be a growth. If it's smaller than 1, it's going to be a decay. I'm not going to go through and do every single one of these. It's the same process over and over. So number 2 says the value of the car. So that's what we're starting with. Loses 12%. So 12% is the same as 0.12. It says I'm losing, so I'm subtracting that from 1. So if I wanted to simplify this, it's going to be 0.88 raised to the x. Okay, what would be the value of the car in 12 years? We're plugging in 12 for the x. Okay, for example 3, it's asking if it can be represented by an exponential function. So something is going to be an exponential function if we are multiplying it or dividing it every week or every month or every day or whatever the unit of time is. So this says a checking account receives 500 deposit each month. This is adding. So this is not exponential. Okay, oops, it says exponential or linear, sorry. So this is going to be linear. The number of people infected by a virus triples. When you triple something, that means you're multiplying by 3. So this is exponential. An unpaid credit card balance accrues interest each month. So when it accrues interest, you're going to be multiplying it by an amount. So this is going to be exponential. A radio station chooses two new game contestants each day. So if I'm choosing 2 new people each day, it would go 2, and then 4, and then 6, and then 8. So how am I getting to the next number? I'm adding, so that's linear. Okay, so if we're adding or subtracting, it's linear. If we're multiplying or dividing, it's exponential. All right, example 4. We have an equation given to us. It says, does the model represent a growth or a decay? We look here, it's bigger than 1, so it's a growth. Okay, we can say because B is greater than 1, it's 1.02. What was the annual percent increase or decrease in the population? So we know that the part inside the parentheses is supposed to be 1 plus R. In this question, our 1 plus r is equal to 1.02. So if I wanted to solve for our r value, I would have to subtract 1 from each side. So that would give me r is 0.02. How do I change 0.02 to a percent? I multiply by 100 and I get it's 2%. What will be the approximate population 9 years after the start of the decade? So I'm plugging in 9. And I just plug that into my calculator. Okay, this one's going to give me a pretty big number. Let's see. 1.02 to the 9th times 2345. So I get 28.02 million because it was already in millions to begin with. Alright, then example 5. The value in dollars of a computer can be approximated by the model, where t is the number of years since the computer was purchased. Does it represent a growth or a decay? So we're focused on this part in here. It's going to be a decay because b is less than 1. Was the annual percent increase or decrease? So since it was decreasing, we know inside the parentheses is 1 minus r. So if I solve for r, I would subtract 1 on both sides, and I get negative r is equal to negative 0.3. So that means positive r is equal to positive 0.3. How do I change this to a percent? I multiply by 100, and I get 30%. Okay, I plug in a 7 to answer the last question. And I get 205.89.